Triangle congruence proofs 2. We're just going to prove more triangles are congruent, just more practice doing proofs. A couple of the big ideas from last class, remember, we go back. We want to use those givens. We want to mark up the diagram, make sure you get 3 sides or angles congruent. And then once you have 3 pairs of sides or angles congruent, we know the triangles are congruent by one of the postulates. All right, so let's look at a couple examples. Oh, real quick. If we had an isosceles triangle, that means 2 sides are equal and 2 angles are equal. And it's always those base angles are equal. So the radius of this circle, right, is one side of the triangle, radius of the circle, other side of the triangle. So that's an isosceles triangle. 2 sides are the same and 2 angles are the same. Just a little definition. All right, so let's look at this first proof. I'll go through it with you, see if we can figure it out. So we're given ABC is an isosceles triangle, ABC. That triangle, the whole big one, with BC as the base. That means we have 2 sides that are equal and 2 angles that are equal. So if we're given that information, I know these 2 sides are equal because BC is the base. So 2. I know AC is equal to AB. Those 2 sides are equal. I also know the angles are equal. I just showed you that little video, or little slider. Those base angles are also equal for the definition of an isosceles triangle. So angle B is equal to angle C, also true. Then we're given DA bisects angle BAC. So this angle is being cut in half by this. So if we cut that angle in half, those 2 halves are equal. So step 4, angle BAD is equal to angle CAD. That's the definition of an angle bisector. So now the triangles are congruent. We got 3 things, so we're done. We got an angle in red. We got those blue sides. We got those green angles. So this is angle, side, angle. So I just used like a little bit of a different given, the isosceles triangle. I use that to help me get 2 things that are equal. Then I use that angle bisector to get the third thing. So we want to just make sure we're using multiple or using different things that were given to try to figure out 3 things that are equal. So for example, if ABCD is a square, in a square the diagonals bisect the angles, prove triangle ADE. So hold on, ADE is this triangle. I want to prove this triangle is equal to ABE. ABE is this triangle. So it's important just to mark down these 2 triangles. I don't even care about these 2. Don't even look at them. All right, so first of all, if it's a square, ABCD is a square. So I know, and that was given. So we're going to write a paragraph proof. I just want to show you, you could write sentences. So what do we know? Well, I know in a square, all the sides are equal. So DA is equal to BA because in a square, all sides are equal. So I'm just writing a paragraph here. Okay, there's one side. I also know that A and E is equal to EA. This side is equal in both triangles because of the reflexive property. So there's 2 things that are equal. I'm going to just clean that up a little. So that's the reflexive property. So I got a side, I got a side. I got these 2 sides are equal. I need one more thing. All right, let's see. I was also given some information. I should always check the given. In a square, the diagonals bisect the angles. So diagonals cut the angle in half. So if this angle is cut in half, this half is equal to this half. So we have that reflexive property. We have those sides equal. So next, I know angle DAE is equal to angle BAE because the diagonals bisect the angles in a square. So now I know those triangles are congruent. I got 3 things. It's by side, angle, side.